Okay, today we're looking at the notes for graphing linear functions from slope-intercept form. So remember, slope-intercept form is y equals mx plus b. Remember m here. This is your slope. This is how fast it's moving either up or down, how fast it's changing. And remember, b is your y-intercept. This is your value of the function when x is 0. Because when x becomes 0, this goes away, and all you're left with is b. Okay, so let's look at over this. So the steps to graphing the linear function is first, identify your y-intercept. So you're going to identify your b value to start, because this is your starting or your initial amount. Okay, so here in problem number 1, we have y equals negative x plus 4. So this positive 4 piece, this is my y-intercept. So that's my starting piece. The next part is identifying my slope. So remember, slope is rise over run. In slope-intercept form, this is the value in front of x. So right now, x, there's only one of them there, but it happens to be negative. So my slope here is actually negative 1. That means I would go down 1 over 1. Every time I go over 1, I have to go down 1. Every time I go over 1, I have to go down 1. Over 1, down 1. Over 1 and down 1. Now, then you connect the 2 points. All you ever need, which remember this is m, all you ever need to graph a linear function is 2 points. Because if you have 2 points, then it's set like this. Okay? If you have 1 point, it can go anywhere you want. But as soon as there's a second point, it has to go in this direction. So then you go ahead and connect these. Now, in problem number 2, it is not written in slope-intercept form. So we have to convert it into slope-intercept form. So, reminder, here's how we convert it into slope-intercept form. The first thing we do is we move this x value over. When we move that x value over, nothing happens to this. Negative 3y equals this positive 2x, because we moved it, becomes negative 2x. And nothing happened to this 15. It's a positive 15 right now. So we have plus 15. Remember, we can't add these two pieces together because they are different terms. I can't take negative 2x and add it to 15. They are not like terms, so there's nothing I can do with it. Okay, so now my next step is I divide by negative 3. And what I'm going to do here, because I want it in this slope-intercept form, I'm going to divide each of these pieces by negative 3. So this one and this one. I am distributing that division to everything. And that's allowed. Just like when we have like 2x plus 3, and we distribute this 2 with multiplication, you get 2x plus 3, or I'm sorry, plus 6. We're distributing that division. It's like 1/2 x plus 3. You're distributing the division, x over 2 plus 3 over 2. You're distributing the division. So here, the benefit is this. This goes away. Gone. Which is what I want, which is what I need. I'm left with y all by itself. 2 divided by 3, that does not come out to a nice number. I'm going to leave it as a fraction. But a negative divided by a negative gives me a positive. So this is 2 over 3x, which actually I'll prefer, and I'll show you a reason why. Here, 15 can be divided by 3. 15 divided by 3 is 5. And a positive divided by a negative is negative. So my equation here in slope-intercept form is y equals 2/3 x minus 5. So the first thing I do is I identify my y-intercept. -5. So I make a dot right down here. The second part, identify my slope. This is actually why I like fractions for graphing. Because remember, it's rise over run. So 2/3 means I rise 2, 1, 2, and I run 3, 1, 2, 3. So I went up 2 and I went over 3. I go up 2, 1, 2, over 3, 1, 2, 3. And I can make my connection here. Don't worry if your line isn't perfect, okay, and it's wobbly or anything like that. You don't need, if you really need to make it a straight line, use the edge of one of the whiteboards, okay? But really, for me, it's being able to convert this to slope-intercept and being able to establish your graph in the right direction. So this part, graphing linear function using the intercepts. So what we can do with this standard form is if the numbers are nice, we can use this standard form to identify our intercepts. And remember, all we ever need is 2 points. Okay? So here's what I mean. Let's say I want to find the x-intercept. I'm going to use red. Well, the x-intercept is a dot that's somewhere along here. And I don't know what x is going to be. But I know this for a fact. My y value is not positive because it's on this line. It's also not negative because it's on this line. So therefore, for my x-intercept, my y value is 0. So here's what this looks like in practice. I don't know what x is. So I'm going to say 2x. I know what y is. Y has to be 0. So I say minus 0 equals 6. Well, 2x minus 0, anything minus 0 just goes away. Who cares? That doesn't matter. I'm left with 2x equals 6. Well, in that case, all I have to do is divide by 2. And I'm left with x equals 3. So my x-intercept is 3, which means this right here, my x-intercept, that's a point on this graph. Okay, let's take this a step further. Let's talk about the y-intercept. Now, the y-intercept, I can either use slope-intercept form, which it's not in, or I set my x equals to 0 for the same reason. If I'm looking for my y-intercept, I don't know what my y is going to be, but I know my x is not positive and not negative. My x is 0. So my x value here is going to be 0. So here's what this looks like in practice. 2x minus y equals 6. I make my x value, I set my x value to 0. So 2 times 0 minus y equals 6. Well, 2 times 0, anything times 0 just goes away. So I'm left with negative y equals 6. Okay, well, this is negative. I'm going to turn it into a positive by dividing by negative 1. Because a negative divided by a negative makes a positive. 1 divided by 1 doesn't do anything. 6 divided by 1 is still 6. But positive 6 divided by negative 1 is negative 6. So this means my second point is negative 6, which is down here. And again, going back to this idea, if I have 1 point, this line can go anywhere. But because I have 2 points, that means my line has to go here. And that would just connect them. And if you're asked to find the slope of this, here's what you do. Remember, slope is rise over run, right? Well, I have this point right here, 6. 1, 2, 3, 4, 5, 6. And it's up, so it's positive. And then run. 1, 2, 3. So my slope for this is 6 divided by 3. So my slope is 2, in case I've ever asked that. All right, last 2 things. I'm graphing horizontal lines and graphing vertical lines. Horizontal lines. Remember, horizontal lines are lines where we're given y equals some number, okay? H stands for, here, I'm going to have to turn this sideways. H stands for horizontal. The O stands for zero slope. And the Y stands for y equals a number or y-intercept. Here's what I mean. This says y equals -4. So I should go right down here to -4 and make a top. Okay? That means no matter what I pick for x, my y value is always -4. So if you pick 4, y is -4. If you pick -5, y is -4. If you pick -1, y is 4. This is the only place my line is. Now, let's look at these concepts again. Horizontal means it's going side to side, okay? This is also a zero slope. It means that it's not going up or not going down. And it's crossing the y-axis because it has a y-intercept. This is why it's y equals a number. So when we graph horizontal lines, this is all we have to do. And we can type that into Desmos and it will graph it for us. Now, let's look at graphing vertical lines. If horizontal lines is y equals a number, vertical lines is going to be x equals a number. Okay? V stands for vertical. U stands for undefined slope because it's going up and down. And X stands for x equals a number or x-intercept. So when you're given x equals -4, that means no matter what y is, x is always going to be -4. So x equals -4, I'm going to start right there. Okay, well, if y is 5, x is -4. If y is -6, x is -4. And you can type this into Desmos to confirm this, but it'll give you this vertical line. This is one of the very few things that you can type into Desmos that will give you a graph, but it's not a function because it is a vertical line, so it does not pass the vertical line test. That's why it has an undefined slope. It is not a function. And that is our notes on having to graph using slope-intercept form.